Hello, ladies and gentlemen. For this video, I'm just going over a few examples from the assignment. This is meant to be a review, just get some extra practice with these radicals. With your test coming up pretty soon, you want to make sure you're good at these things. So I'm just going to do 3 examples, basically one of each type. I'm going to start with number 7. This is where you simplify a single radical. And what you want to do is you take each part individually, each of these factors here, and factor those as much as possible and figure out what you can get out of your radical. So we'll start with 200. 200 is 20 and 10. And then those factor, you got 4 and 5, and 10 is 5 and 2. And then the 4 also factors to pair of 2s. So we got pair of 2s, we got pair of 5s, and then the 2s left over. I'm going to switch to a new color here. So that one's all factored there. The m here is m squared times m, and m squared is m times m. So we got a pair of m's. Oh, I don't want to cover up my 2 there. And then I can move on to my n. Let me pick a different color. All right, so n to the 4th is n squared times n squared, and that's already a pair there, so we'll stop there. Let's see, I'm running out of colors. Orange? Yeah, we'll go with orange. So p to the 3rd is p squared times p, and then you can factor the p squared there. So here's my pairs of things. Anything that's not circled at the end there, that's what gets left over. And so I'm going to come down here. Originally there was a 5. Make sure you still have the 5 there. And now we're going to times by one of each of these pairs here that we got. And so we got 5 times 2 times 5 times m times n squared times p. And then we got what was left inside here. There's a 2, there's an m, and a p. And so we'll put the 2 times m times a p inside. And now we just need to simplify. And by the way, why there's only one of each of these is we're square rooting these. If you do 2 times 2 and you square root it, you get 2. If you do 5 times 5 and square root that, you get 5. So that's why there's only one of them on the outside here. But anyway, we're going to times this together. We got 5 times 2 times 5, which is 50. And we got m, n squared, p. And then inside there, 2mp. And voila, we got our answer. Let's move on to another one. Number 10 here. If you're going to add or subtract radicals, you do have to simplify them to see if they have like terms and see if you can combine them. So we got 8 here, which is 4 times 2. And 4 is 2 times 2, so we got a pair there. 18 is 9 times 2, and 9 is 3 times 3. So you can factor out of 3. So this first term here is going to be 2 from here times this 2 from square rooting 2 times 2. And then inside our radical, we got 2. And we got subtract 2, coming straight down from there, times 3, which is coming out there because we factor it. And then we got a 2 left inside, and so that stays inside. And so that's going to give us 4 root 2 minus 6 root 2. Well, you can combine these because they have the same radicand. And so you got 4 minus 6, which is negative 2, root 2. And voila, you got your answer. And we're going to do one last one, number 19. So when you're multiplying expressions like these where it's got parentheses around it, this has 2 terms, this has 2 terms, you have to distribute both of these to both of these. So we're going to do this in slightly different colors. So I'm going to distribute this first root 5 and times by both of those. When you have a radical times another radical, you times the things in front, the coefficients there, and you times the things inside the radicand together separately. But these don't have any numbers in front, but we're going to have root 5 times root 5, which is going to be root 25. And then root 5 times root 4, which is going to be root 20. And then we're going to do root 3 times both of these. Root 3 times root 5 is going to be root 15. Root 3 times root 4 is going to be root 12. So now we've got this double distribution done. You can go through and simplify these. The square root of 25 is just 5, so we don't need to do factoring there. Let me put it down a little bit more. 20 is 4 times 5, and then you can factor the 4 there to get a pair of 2s. So this is going to give you 2 root 5. 15 is 3 times 5, which that's not a pair of things, so you gotta just leave it as root 15. And then 12 here is 4 times 3, and 4 is 2 times 2. And we can factor out the pair of 2's there to make it to root 3. And now you look through here and see if there's any of these that have the same radicand that you can combine, and none of them do, and so the problem is over. And I'm realizing now that I could have sped this up a little bit by realizing the square root of 4 is just 2. And factored and multiplied by the 2 there. Saved us a little bit of work later in the factoring process. But it's alright. If this was something like 6 or something like that, that would be important, because sometimes you can factor out even after you distribute it. So, there you go. Some examples to get you started.